Welcome back to Code Station 33. Today we are going to look at how to use other kinds of math functions in our Arduino code. In the past, we looked at addition, subtraction, multiplication, and division, and did a deep dive on division, specifically with integer division and how the computer handles that. But how do we do other kinds of math? So what the designers of Arduino have done is they created a way of doing math with some built-in functions. And when I say a built-in function, let's talk about that a little bit. So here's some examples here. A built-in function is a function that somebody wrote code for and taught the computer how to do, and then just named it and told you that you could use it. And you don't need to know how it works. This idea in computer code is called black box abstraction, where we are using something, but we don't really know exactly how it works. So that's okay. We don't really need to know how the computer calculates a cosine, for example. All we need to know is that it can calculate a cosine, and we can use that. If you want to learn about how cosine is calculated, you can do that by looking in your pre-calc class or by doing some research on the internet. There's graphs involved, there's triangles, opposite over adjacent, all that fun kind of stuff. But actually, adjacent over hypotenuse. Sorry about that. I should at least say it correctly. But in terms of what the computer does in the background, none of that's really important. What we really want to know is that the computer can solve the problem and can calculate for us the cosine. So I have written here a little program that just goes through and shows some of the built-in functions that we have access to inside of Arduino. So I figured we'd kind of take a look at these. So the first one here is the cosine, and it can do sine, cosine, tangent. You can do all three of them. But it works in a number system called radians. And if you're not familiar with that, it can be a little confusing. But 3.14, the reason why I put that there is because that's pi. And in terms of a computer, it looks at that 3.14 as radians. And for you, in degrees, that would be 180 degrees. And how does that work? Well, if you think about a circle from 0 to 360 degrees, and you were to mark off on those four corners of a circle, 0, half pi, pi, 1 1/4 pi, or 1.5 pi, and then 2 pi. All the way around a circle is twice pi. That's 360 degrees. Halfway around the circle is just pi. And there's lots of reasons why they did that, and we don't have time here to go into those reasons. But if you're interested, you should definitely do some research about why they use radians versus degrees and why that choice was made for computer science. So in our computer science, though, we are looking at using radians. So this 3.14 means pi, and for those of you who like degrees, it is 180 degrees. So it'll return the cosine. Absolute value really tells a number's distance from 0. So when we're looking at a number like -10, the distance from -10 to 0 is 10 units, and that's what the computer will return. Now notice here, there's a difference between cosine and absolute value. Cosine takes a floating point value, whereas absolute value takes an integer value. Cosine is not going to work without taking a floating point. It needs that particular kind of number to be sent to it. And if it's not, it's going to take an int and make it a floating point. Our programming language has that ability to do that. So if we send it 3, for example, it's going to make it 3.0. But absolute value is kind of special. It can take either integer values or floating point values. It can do either. And it'll leave it as an integer when we do the absolute value, whereas cosine would return a float. Nothing you could do about it. It's going to return a float. Absolute value is going to return an integer if you send an integer to it, and return a float if you send a float to it. Now, this is really a special property of our function here. It's called overloading, where the function has the ability to take on different parameters, either an integer or a float, and do something different depending upon what you send it. So you could send it a integer and have it return an integer, but if you send it a float, it's going to return a float, which is really kind of cool. Sometimes we call this polymorphic behavior, like when you right-click on a computer screen, and depending upon where you right-click, the actions are different. So like if I right-click here, I got that menu. If I right-click up here, I get a different kind of menu. So that's polymorphic behavior, where the computer does something different depending upon where you are clicking and what you are doing. Okay, the next one, modulo. This one is really in computer science, really important in computer science. Modulo math is really remainder math. So if I do 16 modulo 3, what I'm asking is, what is the remainder? Not how many times does 3 go into 16, which is 5. What we really want to know is what's left over after we do that division. What's the remainder? And the answer in this case is 1. There's a remainder of 1 when it gives you the answer. Now, there is something in computer science called floating point modulo, which is a little weird because floating point modulo isn't really a thing in mathematics. It's not something we typically do in math class. But the computer has the ability to do floating point modulo. It's really a bit difficult to understand because when you start with decimals and you do division, you're going to end up with decimals. How do we talk about remainders? Because there already are remainders. So it's a little complex to kind of wrap your head around, and then not something that we really need to dive into at this point in coding. Here's another example of a trig function. Sine, of course, 180. We're going to do it as 3.14, so that's pi. The square root. You should all be familiar with square root. What times what will equal 16. And again, you see how it is taking a integer value. It could actually do both, an integer or a double. The abbreviation for square root's a little weird. It's SQ for the square part and then RT for the root part. So SQRT. Tangent, another trig function. Now, the opposite of doing a trig function is called an arc. So we do an arc. Sine of a half would give us the reverse of sine. So sine of something is equal to a half. And arc sine would allow us to calculate that. Again, if you've done pre-calc, some of this should make sense. If you haven't done pre-calc, eventually get to it, and now you have the ability to do this in code. Your calculator does it too. Your calculator has an arc sine button. Sometimes we call it the -1 sign, where you write its sine and has a -1 after it, so the inverse sine. That's probably how they put it on your calculator because they have less space. In code here, we do ASIN, A standing for arc sine. And I think I did 0 here, and I meant to do 0.5, but we'll just do this. Arc sine of 0. There we go. Natural log. Okay, so this is logarithms. E to a power is when we're looking at natural log. So we're basically saying e to what power is equal to 1.2. What power of e is equal to 1.2? And that's a natural logarithm. In mathematics, often we use the abbreviation ln rather than log. Log in mathematics is typically log base 10, not natural log. But oddly enough, the computer uses the same word log for natural log, and log base 10 is a log with a 10 after it. So this is the same kind of idea, only instead of being base e, it's base 10, and we're asking what power of 10 is equal to 100. So in this case, we know the answer would be 2. 10 to the second is equal to 100. So this is a little weird. In our math class, we use ln, not log, and that's would just be something you could look up if you forgot. It's pretty easy to double check that. Powers, so 2 to the third is 8. We know that. The way we write it inside of a computer, because they don't use the caret symbol when they do that, they use a comma. So they write POW 2, 3, which would mean 2 to the third. This last one's a little weird. I haven't seen this in any other language. It's kind of, redundant if you think about it. Why wouldn't you just do 2 comma 2 using the power function, but or 2 to the second? But this is basically squaring a number. So this would be 4 comma 2, or 4 to the second is really what this is saying. So square 4, and you're going to get 16. Then I just have a little delay here. So when I run this, I set up some numbers, x and y. We didn't actually need those in this case because I didn't use them. There we go. We're going to run the serial monitor at 9600, and we run it. We can see our answers just keep repeating over and over again. In many cases, I used a print to print the text that comes before it, and then a print line to print the actual answer, and that gives me a nice formatting, and you can see that on the screen. Something interesting, I don't know if I've covered before, but suppose you only wanted this to happen once. Well, remember, this setup code up here, we could put all of this code into setup and not in the loop, and it would just run one time. Remember, setup only runs one time. So if you want something just to run once, you can put it inside a setup. So let me clear the serial monitor and just show you that that works. And then the computer's just going to keep running the simulation. See? Just showed up one time. And now the computer's going to keep running this loop with nothing in it. Nothing's happening. But sometimes it's useful to remember that if you just want something to happen one time, and you're just looking at results on the serial monitor, sometimes it's useful to put it up in setup rather than put it up in the loop. And that way we only have it happening one time in our code. So that's it for today. I will see you next time.